Okay, welcome to Chapter 4. For this part of Chapter 4, we will be covering the reactions in Chapter 4, the aqueous reactions, meaning that they happen in solution, and then we'll also apply some molarity and do some stoichiometry with that. Hopefully this chapter will be covered in basically 3 lectures, and we'll have our test shortly after that, and then we'll do all of your reactions before the end of first quarter. So, sorry, let me get to my right clicker here. Oh, never mind, I can just do this. Okay, solutions, we've talked about a lot of this at the beginning. Fly through really. Still going through strong, weak electrolytes, strong dissolve completely. Still going through fast. This is kind of a key here. Strong acids, your HCl, your HBr, all of these ones are strong electrolytes. Granted, they're not ionic compounds, but they will dissolve in solution, making strong bases will also electrolytes. Now this is the key, our soluble ionic salt. A salt is a fancy name for an ionic compound. And last year they had to know and memorize the solubility rules. This year, though, they are giving you the solubility rules. So, lucky you. Okay, but this list is found on page... This list is found on page 127 of your textbook. And so, basically, it's called the solubility rules right here. Solubility rules, and I will give you the list that we'll use on the AP test, but they just tell you what's soluble and what's not. Part of precipitation reactions are being able to say what is soluble and what is not. Okay, so precipitation reactions. When we take 2 clear liquids, notice they're clear, and we pour them together, what you get here, you get precipitate. A precipitate is an insoluble compound. Okay? Insoluble. Sorry, insoluble. I knew there was an L there. Okay? Insoluble, meaning it does not dissolve in water, or a very low percentage of it does dissolve in water. So we get this. Last year we did it was the bottle bewilderment lab. Okay, so now these precipitation reactions bring on a whole new set. We have to start looking at what is being paired up and what their charges are and whether they are soluble or not. We looked at these reactions last year, the metathesis reactions, or the exchange. Last year we called it the double replacement reaction, and we've even looked at this year. Okay, that should be an arrow there. Sorry, it doesn't come up on this program. Okay, but basically our 2 dance partners, and that should be lowercase as well. I mean a subscript, sorry. 3. Basically they're going to switch. So the outs switch with the ins. So we would then get the AgCl and KNO3. And again, that 3 should be a subscript. Okay, all it did, we just knew our charges and our charge. Okay. Again, most precipitation reactions are double replacement. Okay, and then we can start to calculate how much precipitate we should get out and if one will form. Okay, when you're doing a precipitation reaction, pay careful attention. Is it a solid, liquid, gas, or an aqueous? Aqueous is the AQ. If we are to understand reactivity, we must be aware of just what is changing during the course of a reaction. Why do they pair up? Okay, so we have a couple different terms here. Now we have a molecular equation. This is what we've been looking at throughout this whole year. Okay, all of last year and everything. Okay, molecular equations are the whole thing written out. Again, that's an arrow, and that is subscript. That is 2. Okay, so molecular equations you are very, very aware of. Okay, that leads us to an ionic equation. In an ionic equation, all strong electrolytes, strong acids, strong bases, and soluble salts, these come from your solubility rules, which I will give you, are dissociated into their ions, meaning that they will separate. What this does is basically gives us a better reflection of what is actually going on in solution. So, okay, in an ionic equation, remember this started out as, and I'm not going to put the states of matter with it. This started out as AgNO3 plus, sorry, let me erase that, that looks sloppy. AgNO3 plus KCl double replace, and then we get AgCl3 plus KNO3. So this is what we started with. This is our molecular equation. That's an E. Trust me, it really is. Don't worry, my videos will get better. But you're getting knowledge. That's good, and we'll do lots of practice in class. So AgNO3, that's our molecular. Then here, what we did, we looked at our solubility rules, we looked at the strong acids, strong bases, and we said, okay, AgNO3 is going to break into that and that when it's in solution. K, because it's soluble, is going to break into the K ion and the chloride ion in solution. As we looked at our solubility rules, we saw that chlorides, when it's with silver, is not soluble. So that is a solid, and this is your precipitate. Trust me, that says precipitate. Precipitate. Okay? And then the K plus and the NO3 goes into solution. So this would be the silver or the fancy colors that you see coming out, and I'll try and have a demonstration for that. Fast. Okay. Now, just listen to a little bit of the recording. I found out I sound kind of lame. I'm sorry, I need to put some fluctuation into my voice. So, I will try and do that here as I go over the exciting world of net ionic equations. Okay, to form the net ionic equation, cross out anything that does not change from the left side of the equation to the right. So all this is like when you get your paycheck. It's what's left after the taxes are taken out, the net. This is what we'll mainly be dealing with because we don't care about all the word just left me, all the spectator ions. Okay, they're spectators. So what we can do, we simply, existing recording, we just cross out. See how NO3 negative is right there, and we have NO3 negative right here as well. Just cross those out. Okay, they don't affect the reaction any whatsoever. Okay, so we cross out all the ones, boom, K's on the left-hand side, so we cross it out. K's on the right-hand side, you cross it out. It's a spectator. Okay? Now, what does that leave us with? Sorry. Okay. That leaves us with the Ag plus the Cl yields AgCl solid. This is our net ionic equation. We only keep the things that react during the course of the reaction, only the things that are changing. Okay? If it's dissolved in solution and it remains dissolved in solution, then it doesn't change. But these two things, they made a new compound. By George, now we have silver chloride. Okay? Spectator ions. Get rid of those. Now, at certain times on the test, it will ask you for molecular, or it will ask you for complete ionic or net ionic. Okay, to write net ionic equation, first off, write the balanced molecular equation. We can do that. Disassociate. So you look at your rules to see what disassociates. We cross out anything that remains. Our spectator ions. And then we write the net ionic, then we write the ions that remain. Okay? So, take a second, look at this reaction, and see if you can write what is happening with this. Okay, so I'm just going to hit pause here for a second. Okay, we're back. So hopefully you took a little time to find your solubility rules. You can Google those or anything. Again, like I said, I will give you a copy of those. But you can automatically see that right there. Whoa, a laser pointer. How cool is that? Okay, you can see that that's going to be your solid. So you know that your net ionic equation is going to have BaSO4 with the solid. Now, the ions that would make that, we would have to take the Ba, which is 2 plus, and that will be aqueous, plus the SO4 from right here. So
Count, please come to the counseling center. Brendan, Count to the counseling center, please.
AQ. Okay, there's your net ionic equation. Now we can use that and do other things. Okay, then we can also make sure this is balanced. Okay, Ba, SO4, Ba, SO4, we're good there. Okay, I think we will stop here for this first of Riley's ever greatest hits. This is 4.2. We'll have a quiz on Wednesday. Basically, is it can you separate and write net ionic equations? Are you capable of crossing out electrolytes? The next video will cover acid-base reactions as well as oxidation reduction. Great. We'll also go over your test next time. Good luck.